code ask us to do the spline model. So technically, you can do a frame modeling. You could have your pier, and then the deck would be modeled with only one beam element. And then we assign the material property and sectional property of that box into that single beam element. So I open my civil and show you how exactly that's gonna work. This slide show you if you have construction stages, or like this example, which is a balanced cantilever. So you're gonna define different construction stages, different element activates in different times, and different post-tensioning tendon will be applied on them. So if you have such a cases, we can simply model them with a Midas civil. But your project is more like this model. So where we have a wide multi-cell boxes, and we have to use a method so-called grillage approach, where we have to discretize this section into smaller pieces. And if you can imagine, this is gonna be one piece here, one piece of beam here, one I shape here, I shape here, I shape here, and then another irregular shape as a beam element here. So what happens, we have to consider each of these parts as a single beam element with the shapes that you see right here. So and then we are seeing the effect of them. We ensure that they are transversely connected and working as a unit system. They are not working separately. And as you can see, we have to definitely apply the post-tensioning or pre-stressing tendons along the webs as well. Okay, so you can see the difference of using a spline model versus a grillage model. So if you have the spline model, it means entire thing will be modeled only with a single line in the longitudinal direction. But when we are doing the grillage modeling, what happens, we discretize this section into smaller pieces. And as you can see, I gotta have 5 longitudinal elements where they are transversely connected to each other. So this definitely gonna give me more accurate result. I have result for more points, and definitely I'm not ignoring a lot of effect of this wide being wide section. All right, so it depends on the geometry that you your project is. It could be a straight bridge. It could be like having an irregular shape, like what I have here. So you might be you might select different method of modeling and analysis for these cases. That completely depends on the case and what you exactly want from your model. For example, in this model, I can model this, as you can see, is an irregular shape. It has a asymmetric geometry at any direction that you can imagine. So I can simplify it. I want to model exactly the same thing. So I have a couple of ways to do that. I can use the plate element or beam elements. So if I use a beam element and model it with the grillage modeling, so it will be, I have to consider some longitudinal beams going through these directions, and also some transverse beams connecting them to each other. But because the geometry is a kind of irregular, so I need some additional beams like these elements that you can see here to help me to complete the geometry. So this one shows the longitudinal beams, and this one shows the transverse beams that connecting all those together. Another approach is modeling the system with the this bridge with the plate element. So here I use the plate element to model the everything as it is in the real life. Real life. So I can simply model any opening that I have, any stiffeners, longitudinal transfers, or this diaphragm. All of them can be modeled with a plate element. But as I said, each one has its own advantages and own limitations, and depends on the what you want to do with your project, what results you're going to extract from your from this model. You can use either methods. Okay, and also you can model this as a solid element. So today we're going to talk about, like, we are using a beam element, we are using a plate element, and finally we are using a solid element. And then you can see how each one gonna be benefit you in terms of like extracting the exact result and how you can use it for the design. So let me open a Midas civil models that I prepared for you, and then we'll discuss about those in more detail. All right, so let me show you what I'm going to model for you today. So this is the bridge that, we created this bridge based on the drawing that we received from Joe. And let me, okay. If I go to the top view, I can turn off this diaphragm in the beginning, and then you can see the model better. So I assume that all people here at least work with the software once or twice, so they are familiar with the GUI and the different functions that I'm talking about. But if you feel uncomfortable and if you don't know some of these features, please feel free to ask it. Stop me and ask those. I'll be so happy to explain more in detail about those. Okay. All right. So this is the model that I'm going to create for you today. So as you can see, this is a white multi-cell box. Here I use the Grillage model. The Grillage modeling is actually a wizard created in the Midas Civil, just to make it easy to create such a bridges, white multi-cell boxes. This wizard is actually generated based on the Caltrans request, because this type of bridge is pretty hot back in California, and but it's useful for any other states as well. All right. So this is the dimension. I can show you all details. We're gonna have 3 spans. This is the overview of the bridge. We're gonna have 1 span, 2 span, and 3 spans, and we got the diaphragm in the beginning and on the each pier, and connecting them with the rigid links. And if I want to show you that I model this with the beam element, I can convert this or turn off the hidden view, which shows you the exact elements that I used. So as you can see here, this model is created of a combination of some longitudinal and transverse elements, which all of them are beam elements, which are line elements. All right. So let's see how we can utilize this Grillage method, Grillage wizard, to create such a model. To do that, I want to open a new. I want to open a fresh model and start creating those. Before we start using the Grillage method, we have to define this section. So based on the geometry of the section that you have, we can go to the section, go to the node and elements, the properties and section properties. You can add, and under the tab of the PSC or pre-assess and post-tension, you can select multi-cell boxes. Okay. And based on these guide diagrams, you can just enter these dimension right here, and it's gonna be created for you fairly quickly. Now I have one model for you, so you can see how it's created. Just entering this dimension, I got the 6 cell box with this dimension. If you want to change it or modify it anytime during the modeling, you are free to do that. And going back to this, so this will be the prior. So the first step is to define the section, because when we are using the wizard, it actually asks us to use the section which is previously defined. Also, I defined two material for the deck and for pier, but that's okay. You can also model that later on. So that's the only thing that I defined in this model. That's it. So if you want to use the Grillage wizard, we go to the Structure tab, and under the wizard, we can find the Grillage model. So click on the Grillage model. That's what it gives you. So you could have, you have the layout, you have the span information, you have the section informations, and transverse direction element information. So I want to model all of them one by one. So before doing that, I want to open a previously saved wizard, because whatever you do, for example, the dimension that you enter here, the skew that you enter, whatever you do in this dialog box right here, you can save it, and later on you can use it. For example, if you want to have two similar bridges with a different dimension, you can bring this one on, because you already spent a couple of minutes creating this, and then you can just modify the dimensions, everything change, and you're going to get a new model. So let me just open it. Grillage modified model, open. So let's see what we have. First of all, I have the tree span, and each span is 100 feet. If you have a skew angle in the beginning or at the end, you can simply enter those. If you have a couple of the skew angle, you can click on the advanced, and it shows you that at each abutment or each bend cap, what will be the skew angle. So that will be more advanced. But if you want to have all of them set up the same angle, you can just set it up right here. If you have a radius or you have a curved geometry, you can go select this radius and go with the concave or convex, or if you have a multi curves, you can simply follow this method. Here I have only one curve, and I select this. My radius is 300 feet. Now, if I go to the, by the way, you can select these the boundaries, and where will be the fixed supports and all. If you go to the span, you can simply define the dimensions for your abutment, for the spacing from the, the supports and all those here. And also you can define the transverse elements. You remember, we are talking about the grillage method. So in the grillage method, we have the longitudinal elements and then the transverse. So how often or what will be the spacing between the elements, that's completely in your hand and depends on the geometry that you have. Okay, so now what I did here, I used a 2 feet spacing of transverse element. I want to show you how it looks like. And because I used 1 inch here, 1 feet here, 1 feet here, so totally gonna be 98 feet out of 100, and then it's gonna be 49 transverse elements I need to cover entire this section. All right, and then for the transverse element, you can define your section if you want. All right, so we have 3 sections. You could have different dimensions or different properties for each span. That's completely in your hand. But if you want to use all of them at the same time, you can just define it for one of them and click on the copy the current span data to other spans, and it will be automatically copied to the rest of them. All right, so this is the section that I showed you I created. Now you see that the software is showing us these broken lines, which means this is the location that the software breaks down this section and discretizes them. So you have 2 ways to select these elements. One of them is the web-based, which is based on the dimension of the web. So this is more organized, but you can go on the slab-based also. So it will be a little different. So distance from here to here will be similar to here to here, and then gonna be kind of even spacing. But this, as you can see, is more organized. And to see the sectional property of each element or each beam, you can click on the show stiffness and selecting different girders. So you see this one is right here. The third one will be similar to this, has the same sectional property and all. Okay. The same thing here. So if you have different sizes or different dimensions for if you are the different sections, also for different spans, you can also simply do that. For the transverse dimensions, you can simply define where is your shoulder, or if you have a barrier, you can simply define them, and based on the size of those, we can apply the dead load or linear barrier loads. Under the load, you can define different type of load. You can consider the self-weight, you can consider the pavement. If you select that, just enter the pavement thickness and also the weight density. It automatically will be applied on the structure as a distributed load. If you have a barrier, it's going to be do the same thing. So whatever load that you want, you can simply select it here. In this model, for simplicity, I just selected the self-weight. But as you can see, you have a variety of options, like a temperature gradient, wind load, settlement, sidewalks, and all those others that we just defined. All right. You can also define the tendon profiles right here. There are two options. You can define it here and add them. So what you need to do, just enter the X, Y, or if you go with the 3D, you enter the X, Y, Z coordinate for each element and define them here. But there is easier way also. After we created the method model, so we can go ahead and define the tendon profile later on for them. Also, if you have a reinforcement, you can define it here. But in this model, I didn't define any reinforcements. All right. So when we done that, so we can just simply say, okay, I'm waiting for the model software to create the model for us. Always it's good habit to have eyes on the message window, because if you entered some dimension by mistakes or something does not are not compatible, software give you the warning or give you the error, so you can find it yourself what's the issue. All right, so this is exactly like the model that they have. So you saw how quickly we were able to create such a geometry. And if I turn off this abutment right here, so if I go to the section abutment 1, I can just double click on that, select it, and we can just hide it. All right. So it's exactly the same sections, and you see we have 3 spans. If you want to turn off the nodes that are in your way, you can just simply click on this option, display option, and uncheck nodes, OK, and you have a more clear view. All right. So now we can define the tendon profile for these elements. So for defining the tendon profile, you can simply go to the load, temperature and pre-stress, tendon properties, add, for example, I call it tendon. Here I'm defining the tendon properties. So for the tendons, we have 3 types of tendon available in Midas Civil. We have pre-stress, we have post-tension, and we have external. And the thing is, in Midas Civil, you can use all 3 of them at the same time. For example, if you have a spliced girder bridge, you can use the pre-stress elements, and later on, you can splice them all together and post-tension them all the pre-stress element together. Or if you have a staged post-tensioning, that's also available in Midas Civil. You can post-tension different element at different different stage of construction. All right, for this, let's say internal post-tension, we need to define the material. So for define material, if you don't have your material already defined here, what we can do, we can just simply click on this square with 3 dots, and it's gonna bring it up for me, and I can define my material. So click add, and under the steel we can select the 270 low relaxation steel. Okay. Total area, so I can simply define it. Let's say I have 21 of those. Okay, so this will be the total area of each tendon. And the duct diameter, whenever we have the post tensioning, so we definitely need to define the duct diameter. And always keep in mind that this duct diameter should be larger than the the total tendon diameter, because it common sense, it has to fit in there. So we'll go with the 0.2. Yeah, and okay. Okay, now we can define the tendon profile. So for defining the tendon profile, I wanna just use the one that I already defined and define it for you. See how easily we can play with that, and how easily we can copy one element to another. So I want to just open. So okay, I ensure that I'm in the feet and hips. So anytime during the modeling, you can modify, change the units from one to another if you have your input based on the different methods. All right. So this will be the tendon profile that I want to define. So whenever I have here, you can see the tendon profile is very small because we have a 300 feet long bridge, so you can't see these changes that much, but when I create it, you can see them better. But you can get some idea about how it's going to look like. And on the abutment, first abutment, it's going to be somehow above the neutral axis, then it goes down, and again on the first support goes up, down, so you can see that's following the bending moment diagrams, and we're going to define it that way. If you have the coordinate of the tendons, like what you see here, you can simply copy it from Excel and paste it right here. What I do, I just copy this from the other model that I have, and in the new model that we have right here, I go to the tendon profile, say add, I call it tendon 1, T1. Tendon property will be tendon, and assign element, I gotta select all those. Before that, I want to just enter these dimension, paste it here, and you can see exactly the same thing is created. So depends on the complexity of the elements that you have, the complexity of the geometry that you have. You may enter them like very simply, or very like you need more, be more cautious. For example, if I had only one span bridge, or I want to just apply the post tension tendon only on these elements right here, so it was definitely very easier for me just to do not need to define 3 points, one here, one in the middle, one at the end, and the software will find the best fit curve to go through those 3 points. So that's very easy. So now here I have 1, 2, 3, 4, 5, 6, 7 points to create a model. Or if you have more points, definitely gonna be better. So these gonna be the elements that I want to assign them to. All right. Or what I do, I just go to the top view and turn off the nodes. I want to assign the first one to the first element right here. So I say add, I call it T1, selecting this one. Instead of 285, what I do, I need to define the aligned element. So what I do, I just simply select this, select by the polygon, because we are in a curve. If you are in a straight element, a straight geometry, I was able to select the by single and then create a window, and it's gonna create it for me. So for example, right here, it's gonna select it. But now, because we're in a curved geometry, I go with the polygon. So to show you how the polygon works, so simply you can just draw some lines and include your right here. So everything is selected. The only thing that I don't want to select are these elements right here. So I can simply unselect. So that's unselected, and this one should be unselected as well. And I think we are good to go. Yes, everything is selected now, and again I go to the selecting the 3D. If you select the 2D, it's gonna be the X and Y. So it's gonna, if you imagine the section, it's gonna be X and Y related to the sections. But now, if I go with the 3D, I can enter the X, Y, and Z, and I can just shift it to the left and right, and in any dimension, dimension that I want. Apply. Everything is fine. So the first element to be assigned to, I'm gonna select element 1 and apply. Okay. So so far I defined only one tendon. If you want to see the tendon itself, so this is the coordinate, the layout of the tendon. So if I go to the side, maybe you can see it better, but because it's in a curve, maybe you cannot see it that nice. This will be the main geometry. If I go to the 3D view, you can also see that it goes exactly through the web, side web. If you want to rotate it to just fit it exactly in the web and then have it is inclined, that's also available. You can simply do that by just entering some, x-axis angle. So it's going to simply rotate it about the x-axis. All right. So now I created one of those. What I want to do, I want to just assign it to the, another element. For example, I want to go with the next element right here. So what I do, I need to just go to the tendon profile, click on that, and instead of creating a new one, I can just say copy or move. And this time I said that assign to a new element. So I select the new elements right here, the same way that I selected the other elements, polygon. Alright, so these are a new element, and the first element to be assigned to is this one, and add it. So now you can select all the elements that you want to apply to. So the next one will be selecting from, I want to just do it for 2 of them, and then just leave the rest of them for your practice, because it's going to be exactly the same approach, not a big difference. So you can select them all at the same time, and as you can consider, can see here in the model, the dimension of the add. So I selected 2 sets, but if you look at this, the total length of this exterior girder with the interior girders are definitely don't have the same size. And definitely the interior one also don't have the same size because they're getting smaller and smaller. But how to fit those? Software has one option here, auto adjustment of the tendon length. So if you check this, software automatically can adjust the length for you, either shrink it or stretch it to fit to the right direction. So alright, so you saw how easily we created the 2 other tendon profiles right here. Okay, so you can just turn them on or off to see all three tendon profiles available. Okay, so that's that easy to create them. So I just want to show you what's going on there, and keep moving on, and then show you the other options. So later on, when you want to apply the pre-stressing tendons, you can go with the tendon pre-stress and select, for example, all three of them, add it to the right box, which is a selected box. And for the post-tensioning, you have two options. You can go with the beginning. I mean, post-tension is from one end, from the beginning, from the end, or from the both ends. So definitely, when you are post-tensioning it from both sides, so technically you're gonna have lesser friction loss because of the shape of the tendon profiles. But that's completely in your hand. Depends on the geometry, depends on the equipment that you have, and completely in your design. Which one you want to do? Let's say going from the both ends, and from each end I can apply the pre-stressing or post-tensioning forces, both as a stress or as a force. So if you know exactly force that you want to apply on the structure, on those tendons, just apply them. Just go with the force and then as a kick. If you don't, and you know it as a stress, so you can enter them as a stress. So we know that low relaxation tendon loss has 270. So we can go with something around 80% of that, or let's say 200 KSI. And add, it's all loaded. So all of these elements are post-tension right now. Okay. So the method that I showed you today is using the Grillage model method, and we applied the tendon. I showed you how you can copy the tendon profiles and how you can apply the post-tension. Now another things that is important in the post-tensioning and pre-stressing is time-dependent analysis. To define the time-dependent material, we can go to the properties, and you can find them as a creep and shrinkage and compressive strength. So here are the parts that you can find the time-dependent material property. If I click on the creep and shrinkage and add, you have options to select based on the code, like CBFIP, ACI, ASHTO, and PCA, if the one that you want. Let's say if you go with the ASHTO, you can call it creep, shrink, and just enter the compressive strength of concrete, which let's say we are using a 8 KSI. Volume ratio, volume to surface ratio, let's say is 10, and age of the concrete in beginning of the shrinkage would be 3. Okay, so if you use the code, that's very easy software. You can just see the these curves, and then the software uses the internal iterative method to find the corresponding creep and shrinkage coefficients, okay, and use it in the calculation of those losses. And the same way you can define the compressive strength of concrete. So the compressive strength of concrete is also important, especially when you have casting place bridges, or you have a post-tensioning bridge project where you want to study, you want to monitor the behavior of the early age concrete for the, let's say, cracks, for the deformations and all, because it takes about 4 weeks that the concrete can come up with the ultimate strength, and we can just fully load it. So before that, we can use the either code, or we can go with the user-defined coefficient. Let's say we are following the ACI code and entering the F prime C as an 8K, and these parameters 1 and 1, and I can draw the graph. I call it compressive strength of concrete. All right, and this will be the curve. So you see that after 28 days, almost remains flat, which means it reached the ultimate strength. Okay, so this is how you define the, consider the time-dependent material properties. And this is important. For example, in this model that I created for you, if you want to consider the creep and shrinkage and compressive strength of concrete for, let's say, only this part of structure. Let's say you have this part is already existing, so you don't want to apply those material properties to those parts, and you want to see it only on this element. So what you can do, you can just link it to a material property at this site. So we have the option for the material link. So you can select the concrete or material that you have, add it, and from the creep, you can select the creep function that we just defined, and for the compressive strength, you can define that as well, and then say add it. Now this concrete, whenever you use this concrete, it automatically considers the creep and shrinkage function that you defined, and also the compressive strength of concrete. And please know that whenever you are using the time-dependent properties, we have to go through the construction stage analysis, because from the name also you can say that this is a time-dependent properties, which means we have to have some time-dependent analysis to be able to consider those properties. Okay. That's pretty much about the modeling. I can open the model that I have completed right here. So you can see this is a complete model, and you know, this model is actually has more element compared to the one that I just created for you, because I used the smaller transverse elements to just come up with a more accurate result. That's an option that's completely in your hands. And I can turn this off. Alright, and here I also defined the construction stages. So just show you what's the construction stage. In construction stage 1, let me show you this one. In construction stage 1, we have just the you know, the longitudinal elements and the post-tensioning tendons, like half of them, because they have 42. In the stage 2, after we consider the creep, we see that this alright, so the diaphragm should be activated, and you know, we get the rest of the result. And for the calculating the total creep, I defined actually 1,000 day. So code asks us to go with the 10,000 days, so we can simply define the 10,000 day, and then the software calculates the final losses for you at the end of the 10,000 day. And you know, if you want any additional steps in between, it can be easily created. All right, that's it. That's the first method that I want to show you. So this way you saw that how we can use the grillage modeling to create such a model. Okay, and that's exactly the same as you know, other type of modeling. So you want to change anything, you can simply change them. You want to add anything, you want to rotate them, you want to change the material, change the coordinates of the nodes and elements, easily you can do. So anytime that you use these wizards, you can completely free to change anything. All right, this is the first method. Method 2 will be using the plate element to create the such a geometry. So for showing you some of those and saving some time, I prepared one one model for you. So this is the one that I showed you, has kind of asymmetric geometry, and I used the plate element to completely model everything. All right, so everything like a slab, the bottom, and the sides, and also the stiffeners inside them is all modeled with the plate element. So to show you the plate element, I can select these parts, unselect these guys, and if I go to the top view, you can see how it is modeled. So I have the stiffeners, I have these opening right here, And if I want to post tension these guys, the longitudinal elements right here, that's similar to a beam or kind of stiffeners, I can post tension those elements. If I want to post tension the bottom slab, I can do that as well. There is just one thing. In Midas Civil, if you want to do the post tension or pre-stress the slabs, we can do that automatically. So we don't have tools for the modeling it automatically, and because of that, we are using the FEA software to do all of those. For if you want to pre-stress or post tension the solid and plate element, you can use the FEA. I'm going to show you how easily you can utilize FEA for that one. But in Midas Civil, you can do that, and there is some workaround for it. Okay. So I'm going to show you what's the workaround. So for example, if you have this plate, let's say you want to just post tension this element, what you do, you just define a beam in middle of this slab right here. For example, I can just define a beam. It could be on a curve or it could be on a straight element, doesn't matter. And then we can post tension that element, that beam element. So there should be some assumptions and some simplification to ensure that everything goes smoothly and everything, comes up with the correct result that we are looking for. Let me turn this off. All right. So for example, I can simply create a beam. Going to the node and element, create a beam. I can select any element that I want, or I can see from this point to that point will be a beam. And now I can just post tension that beam, define the tendon profile, exactly the same tendon profile that I want to define on that plate, and simply apply it to the beam. But you have to be careful about the the losses that you get from here, and also the the size of the dimension of the dummy beams that we are using here. So those are kind of sensitive, and you have to come up with some equilibrium equilibrium to those section and then the losses. All right, I can explain more in detail in that cases. But in anyhow that you want to model the model as a plate element or a solid element, which is a common practice also for some projects, what you can do, we can go through the FEA software. So I'm not sure how many of you are familiar with the Midas FEA, but that's a 3D that's a 3D software for doing the detailed analysis, and you have a variety of options to create solid beam and plate element. You can pre-stress and post-tension all of those. You have option to define the reinforcement or any post-tensioning or pre-stressing tendons in any geometry that you want. You can study the time-dependent analysis. So let me open Midas FEA and show you how easily and more cleanly you can work around with this, if you want to model the entire structure with these solid elements or with the plate element. Please give me 1 minute to open this. All right, so this is Midas FEA, and what I have for you here is the same slab. I just modeled all as a one part, but we can simply define it in the different dimensions as well. So I want to show you this as a demo. Let me show you some of these transparency parts. All right. So this is the solid that I have. This is a slab with the exact circular shapes, and I defined all those curves and also the tendons inside them. I can just go with the wireframe, and you can see the pre-stressing or post-tensioning tendons inside this. So this is very, very simple to create such a model in, although this is a 3D modeling, 3D finite element tool, and I can create the solid elements and then post-tension those. Very easy to create those dimensions. For example, if I turn off this, if I turn off that solid, and also if I turn off the rest of them, entire the mesh, okay. All right. All right. So let me turn off the notes as well. All right. So you see, if I have only the my section, so this will be my section, which you can easily create it right here, or you can simply create it. All right. So you can simply create a section right here in Midas FEA, or you can, if you have it in AutoCAD, you can simply create it there and import it into Midas. Simply, you can generate the solid elements here, or if you want to model it with the plate, you can do it with the plate. But I recommend, if you want to do it with FEA, go with the more accurate result with solid, because the analysis time doesn't take much longer if you do plate or the solid in this simple model. So what we do, we can simply generate it for. I can generate it for you. For example, I have this curved geometry, and go to the solid and sweep it. Select the profile. You can select this and select the guide curve, which will be this guide curve. Before that, I need to all right, apply. Okay, so now we are ready. We go to the sweep, select the profile, and going with the wire, I can just sweep this through the this guide curve, and we can just simply create such a solid that easily. And if you have any if it's a hollow section, you can easily extrude these dimensions from that, and it will be created for you in a second. So you can see how easily you can create this geometry in Midas FEA. But I already have that, so I don't want to create additional one. So this is the section that they have. All right, so you can see the bottom, sides, and all those holes. These nodes that you can see here, these are the location of the tendon profile that I want to define here. And I can simply select them and do the meshing. I'm going to show you the meshes also. because we don't have time, I want to just quickly show you a couple of the options. If you guys are interested to know more about the FEA or how we handle different parts or the capability of the FEA, please feel free to let us know, and we definitely give you more details about this. All right, and if I go to the mesh parts, I can simply show you this, and you see how easily I can just create a mesh, automatic mesh, and you know, all these circles are exactly as they are. We can simply define the reinforcement. So I use the reinforcement and define the, so if I turn the other ones off, so you can see this better. Alright, so these are the tendon profiles. I assign the pre-stressing, post-tension tendon property to that. If you want to define any linear or non-linear material, you can define for that. For example, under the material, I have two materials. One is the concrete, which is the I use the C8000, which is you know, 8,000 psi concrete. For this model, I use only the elastic property. But if you want to study the inelastic properties, you can simply select different models that we have right here. Okay. And for the elastic modulus, you can also define some functions. So it could be like elastically changing the material property. So it's still inelastic, but it can go to the, having a non-linear elastic behavior. The same thing for the Poisson ratio, and then the expansion coefficient. And also here you can consider the time-dependent behavior. Same thing for the creep and shrinkage, and also compressive strength of concrete. And this is very, very similar to what you saw in the Midas FEA, Midas Civil. And also for the material that you want to define, if you have your own elastic modulus or all the, you know, weight density, all the material property, you can just punch them in. But if you want to grab it from the you know, library, you can click on this option, database, and select a different material property, both for steel and concrete or any other material, right from this library. For the thermal coefficients, you can just click on these icons, and it shows you different options. You can just enter them and use them for the different type of analysis. The same thing for the steel. For the steel also, you can go with a different type of nonlinearity for the concrete, for the pre-stressing tendons. It's very easy to follow this method. You can simply apply the boundary conditions and define the construction stages. Also, to a certain point, the moving load analysis. So it's all I want to share with you today, and showing you how we can use Midas FEA and Midas Civil for the multi-cell box sections. Hopefully you got some idea about how we can use those options. If you have detailed questions and want to know how the software handling different type of analysis, or how we can use it for the design, please feel free to contact us, because in Midas Civil, after we've done the modeling, we can also go through the complete design, and you know, based on the H2LRFT 2012, we can set up everything for that, and the software give us a complete design report as well, as per H2LRFT. So if you want more details, please feel free to contact us. Thank you so much, and I keep the session open. If you guys have any questions, please feel free to ask those questions. I will be so happy to answer them. Thank you. Joe asked a question that what does the Grillage wizard uses for transfers links? Actually, the transfers are not links; they are elements. So let me show you. For example, for these elements right here, it automatically considers those connections with the small beam elements. So that's what software automatically does. So you don't need to be worried about that. But if you want to change them, you can simply change it from here. So to answer that better, Joe, we normally use the, when we're defining the transfers elements, we normally use the slab width of the section because but what happens is that these elements, because they are perpendicular to the longitudinal directions, they are not actually playing any role or adding any stiffness to the longitudinal direction stiffness. So you can use any section, but normally what we do, we use the same thickness of as the top slab. So for this model, we can use the top flange elements. So the transfers element technically ensure that the girders are working together, and also ensures that there is the torsional stiffness or the lateral stiffness in that direction. That's very easy to create. Let me turn off the. Joe asked if we can create the nodes or elements on a curve if we are not using a grillage. But to show that, please let me turn off everything here. So hide. And if I have like a nodes, 3 nodes, let me just create some nodes. So I go to the nodes and create nodes. Let's say the first node, I want to put it on the feet. Okay, so the first node will be 0, 0, 0, apply. The second one will be, for example, 100 and 0 and 0, and the other one would be, let's say, 50 and 50, 10 and 0. Okay, so I just wanted to create some nodes. Let me turn on the nodes so you can see them. All right, where are my 3 nodes? Okay, apply. Okay, let me just create them from 0, 0, 0, apply, and then 100 and 0 and 0 and apply, and this time would be 50 and Y will be 10 and 0, apply. Okay, so I have all these 3 nodes. If I want to create a curve geometry, I can go to the structure, so to the node and element, and here we have option: create the elements on create the line elements on curve. So you have variety of options. You can go with the arc by 3 points, arc by center and 2 points, circle, ellipse, parabolic, and let's say do the arc by 3 points. So for that reason, you need just to select 3 points, which will be point 1, point 2, and finally point 3. 0, 0, and 0. It didn't create the point 0 for me. Okay, so I can go to the create lines on the elements, and 3 points will be this point, that point, and this point. And by default, it has, okay, it created so many of them because I'm using this on the other elements. So anyway, you can simply create those. These are intersecting with everything else. So the best way will be, anyway, you can just simply use that option to create any nodes and elements that you want on your model. Okay, so it should be all these 3 points. And now I can go to the creating this from the, let's say, arc by 3 points from here to here and to here. And you see that the lines are created for me. Depends on the number of division that you want. You can just change this from 8. 8 is default. So you can change it to, let's say, 40 elements. So let me see. Let me show you if I change it to the 40 element, what's going to happen. From here to here to here, you see it gives us a smaller dimension beams, and then all the nodes will be correspondent to this, you know, the geometry that you have. So all these are available now also for you. So there are some features on Midas Civil if you are not familiar with that. For example, you can select any element that you want, and from the list of the sections from the tree menu, you can just simply drag it and drop it here. It can automatically change the section to the one that you want. The same thing for the material property. For example, I want to assign the concrete pier to that. I can just drag it and drop it. It automatically changes the material property right here. Okay, if you guys have more questions, please ask them. Yes, they asked if we are using the Grillage model, is it just a combination of some of the line elements or beam elements that you know, put together as the same model? Yes, it is, and it's make it so easy to do the design also later on, and also it make it so easy to extract the results on those. And as I showed you, you can simply define any tendon profile for all these girders. Yes, another question is because we use in the grillage modeling, as we discussed in the beginning of this presentation, the grillage modeling is when we are using a longitudinal and transverse. So technically, the longitudinal element, let me show you here. These longitudinal elements ensure that the general bending behavior of the structure is satisfied, and we guarantee that those are working in that direction. And the transverse elements ensures that these girders, the separate girders right here, they are working as a one unit, because in the real life they are not separate. We are just using these methods to simplify it and make it easier to do the analysis, but in real life they are one part. Therefore, we are using these transverse elements. So these transverse elements do two actions. One, keep these main girders together, and they are working as a one unit and one system. And another action is it's just giving the additional torsional behavior, torsional stiffness. So if you can imagine that if you want to bend this one in the x direction, so out of plane, it easily can rotate, right? If it's just one of these girders right here. But if you're going to keep them all together, so definitely we have a larger torsional bending stiffness in the out of plane directions. So that will be guaranteed as well. So especially when we are coming to the curved geometry, maybe for straight, we don't feel it that much of the difference, because it's kind of symmetric. Every load is kind of goes vertically, so we don't feel it that much. But when it comes to the curved geometry or irregular shapes, then is the time that we see the effect of these transverse elements for guaranteeing those lateral stiffness more and more. All right, thanks everyone. I'm not receiving more questions, so I finished the session at this point. And if you guys have any questions, please feel free to contact us. You can email us at T as a technical, S as a support at midasuser.com, or you can directly give us a call. Thank you so much, and have a good evening.
The organizer has ended the session, and this call will be disconnected.